Hello everybody, myself Jyoti and this is first lecture on Raman spectroscopy. Sir C.V. Raman in 1928 he discovered an effect which is called as Raman effect. So what happens in case of Raman effect? Basically here the sample which we take, it may be in solid form, liquid form or gaseous form. When a monochromatic beam of radiation it passes through a substance which may be in any form, solid, liquid or gaseous, then whatever scattered light which we get, it doesn't have a frequency which is equal to frequency of scatter incident radiation only, but in addition to that it has two more frequencies. One which is which is slightly higher than the frequency of incident radiation, and another less than the frequency of incident radiation. So what is Raman effect? Basically the scattered radiation, it consists of three frequencies. One frequency which is same as that of the incident radiation, another frequency which is having frequency slightly higher than the frequency of incident radiation, and the third one which has frequency lower than the frequency of incident radiation. Now this Raman effect we can uh, express in terms of wavelength also. So we can say that in case of when a beam of monochromatic light it passes through a substance, the scattered radiation it consists of three wavelengths. We know so one radiation it will have wavelength which is equals to same as that of the wavelength of incident radiation, and two other, one with higher wavelength and another third one with a lower wavelength as compared to the incident radiation. Now, so as we have three components of scattered radiation, one which with the same frequency or wavelength and another two with higher or lower frequency, the lines whose frequencies have been modified in Raman effect, whether it is higher than the incident radiation or lower than the incident radiation, these two frequencies which we get in the scattered radiation, these lines are called as Raman lines. Now we have two lines, Stokes lines and anti-Stokes lines. So as I discussed earlier, we have three components. One which is having frequency same as that of the incident radiation. Other two will have higher and lower frequency as compared to incident radiation. So Raman line which is having wavelength greater than the wavelength of incident radiation is called Stokes line, and Raman line which is having wavelength shorter than the wavelength of incident radiation is called anti-Stokes line. Here I have defined the Stokes line and anti-Stokes line in terms of wavelength. You can define it in terms of frequency. We know that frequency and wavelength, they are inversely proportional. So how can I define a Raman line which is having frequency less than the frequency of incident radiation is called as Stokes line. Raman line which is having frequency greater than the frequency of incident radiation is called anti-Stokes line. So remember, Stokes line यानी जिसका frequency इंसिडेंट फ्रीक्वेंसी से कम है, एंड एंटी स्टोक्स लाइन यानी जिसका फ्रीक्वेंसी इंसिडेंट फ्रीक्वेंसी से ज़्यादा है. Now let us define Raman shift. Suppose nu I is the frequency of incident radiation and nu S it is the frequency of scattered radiation. Difference between the frequency of incident radiation and scattered radiation is called as Raman shift, and we know that for Stokes line frequency of Stokes line it is less as compared to frequency of incident radiation. That means nu S it is less as compared to nu I, and that is how this Raman shift delta nu it will be positive. And we know that for anti-Stokes line frequency of anti-Stokes line it is higher. That means nu S scattered radiation frequency of scattered radiation will be higher for anti-Stokes line, and that is how this difference nu I minus nu S it will be negative. Now there are certain observations or we can say characteristics of Raman effect. So right now we will just discuss what are the different characteristics, and in the next lecture we will we are going to study each and every characteristic, or rather we will prove each and every characteristic in detail. So first is, when we talk about Raman shift, it is a characteristic of the substance. It depends upon the substance or sample which is under study, and it is independent of frequency of incident radiation. So Raman shift does not depend upon what is the frequency of incident radiation. And second characteristic is this Raman effect or Raman shift, basically not effect. Raman shift is very small, and because of that we require a highly monochromatic radiation and very sensitive detectors to detect Raman shift. This Raman shift, it lies within far and near infrared region, and usually, the intensity of Stokes line is greater than the intensity of anti-Stokes line. In next lecture, we will study why it is like that. And Stokes line and anti-Stokes line, they are symmetrically placed about the parent line. Parent line यानी जो वो line जिसका frequency same होता है as that of the incident radiation. So that is called as parent line, or it is called as unmodified line, या फिर it is called as unperturbed line. And दो लाइंस जिसका फ्रीक्वेंसी चेंज हो गया, तो दे आर कॉल्ड एज रमन लाइंस, और दे आर कॉल्ड एज मॉडिफाइड लाइंस, और दे आर कॉल्ड एज perturbed lines. So it was found that value of Raman shift correspond to frequencies present in the vibrational and rotational spectra of the molecules of the substance through which the incident light is passed. And this leads to conclude that changes in energy of the scattered light in Raman effect correspond to the energy changes accompanying rotational and vibrational transition in a molecule. So this Raman shift basically depends upon rotational and vibrational transition. So this also we will study in detail in the later part. Raman lines are strongly polarized, and Raman effect can be observed even in homonuclear molecules. When we studied the vibrational spectra and rotational spectroscopy, that time we have seen that rotational spectra and vibrational spectra, it is not possible for homonuclear molecule. That can be observed only case of heteronuclear molecule. But this Raman effect, it can be observed even in homonuclear molecules, and hence it increases the range and type of molecules which can be studied. So there are restrictions which molecules can be studied in case of vibrational and rotational, but Raman's spectroscopy, it can be used for homonuclear molecules as well as heteronuclear molecules. So this lecture was about giving an introduction about Raman spectroscopy. In next lecture, what we will focus on is quantum theory of radiation of Raman effect. So Raman effect, we are going to study two theories. One is quantum theory and second is classical theory. In next lecture, we will first study quantum theory of Raman effect. So thank you so much.